So the second part is about agriculture university. I have chosen the topic in such a way that so for the student community, I just put one or two case studies in India. So the leading scientific like a institute, the top leading institute in India and the second in the world. So we have 37 laboratories like IPAR and agriculture research. So we have classified into five, like a physical science, chemical, biological, engineering, and information science. We have a cluster. So totally 27 laboratories, 3,500 scientists. We are working with the different aspects of industrial application of applications. So in particular, we have a secretary that is located in the laboratory. We have 5 major divisions. The one is commercial productions, plating, metal finishing. The third one is electro-organic, and I am from the electronics and electrocatalysis. We do have that electrochemical power sources and electrochemical process engineering. So this is the overall work what we are focusing on. For example, electrochemical process engineering people, there are a group of people, they are focusing on how to reduce the environmental gases like a capture of CO2, and sometimes they also do work on the conversion of CO2 into better plants. Like in the material production case, they are all the major infrastructure of India. For example, the large business, most of the oil companies or other things, they are trying to find out applications. The same way we have electrical power sources to develop improvement batteries to replace the China-based product which is largely available in the market. So we do have electroplating and metal finishing, which is nothing but all the components and other things. So in particular to our division, we do work on development of sensor, the major area for various applications, including agriculture, soil, water, and environmental health monitoring. That is the development of sensor for monitoring of various factors. And also we are focusing to develop some materials that can convert the water into chemicals to reduce the CO2 emissions. We also have electro-organic people. They are working for the green food synthesis of pharmaceuticals and other chemicals. So these are the overall work which is going in the CSIR degree. So the main focus we are having that sensors. For example, if you take a mobile phone, there are at least 1 or 2 sensors which is being used for various applications. Sensor is nothing but a device that provides a continuous information about the environment. So environment, it may be soil, water, or maybe a human being or animals. So in general, the chemical sensor use some kind of chemical materials that can specifically interact with the carbon analyze. For example, if I want to identify the concentration of chromium in the effluent, I can design and activate that the code can easily capture the chromium and make some chemical reaction. That chemical reaction will produce some current that can be detected in the sensor device. So, if chemical sensor, there is a selective layer which can directly interact with the target analyte. So, if we can convert the analyte through the transstitution and get readable signal. This is the simplest concept. So, what is the necessary We all know that most of the detection or determination, quantification, whatever may be, detection method for the analytic molecule. This is the simplest group of our divisions. For the students, some of the commercially.
Sir, excuse me, sir. The session is recorded online, sir. Please stand in front of the camera, please. Thank you. Thank you so much.
Okay. So these are all the some of the commercial material, commercial sensor available in the markets. For example, glucose sensor, alcohol meters, and many sensor that is being used for IoT and monitoring of various gases. This is another example kind of pregnancy testing kit and COVID test kit. So I also give some information regarding the soil sensor now which is available in the markets. There are numerous sensors available. You can ask, sir, what is the new or what we are going to replace? Yes. So every sensor is available in the market. The problem with the sensor, either it may be highly expensive. For example, there is a soil sensor available in the market. The cost may be vary between 20,000 to 30,000. But we don't have any control. We don't have any like a parameter to comparisons. So there is a no specific information on the particular company where they are producing, what is the structural specification of the particular sensor. So in such case, the reliability or maybe a reproducibility of the sensor is highly questionable. So to overcome this issue, we are trying to develop our own indigenous device that can give a reliable information to the environments. So we are focusing on these particular electrochemical sensor measurement. So how many of you already seen this pH meter in the laboratory? Almost everyone, at least somehow we cross that. So these pH meter come under the classification of potentiometric sensors. Okay. In the glass electrodes, what we are using, there is a chemical solution called KCl. That is a potassium chloride, which is already filled inside. There is a small glass bubble is there. It acts as a membrane. There is a different concentration difference between the ions inside and the solutions. So these we are measuring and it gives the corresponding pH. So in the same way, now people are trying to work for many potentiometric sensor to know the concentration of various ions in the blood, urine, as well as in the soil and waters. So the another category called amperometric sensor, the best example which is available in the market is a glucometer. So here, what people are doing, they fix some potential as a constant and they are measuring the current value during the chemical reactions. The same way, we also have so many sensors in the conductometrics, for example, gas sensors. If you want to measure the gas concentration in the particular environment, for example, if you want to measure the CO2 level in the environment in this room, we have a commercially available sensor that you just fix in here somewhere. It will continuously measure the CO2 level by the principle which are involved in the conductometric variation. That is the conductance based sensors. So as we discussed, so these sensor, that is a portable sensor, can replace the commercial based instrumentations. For example, in the commercial, like a blood monitoring, the average cost between 200 to 2,000 rupees depending on the analysis. For example, if you want to measure the glucose level, now we can have the device. If you pay like a 30 rupees or 50 rupees in the Apollo clinic, they will give your total glucose level. But if you want to measure your thyroid, we have to pay at least 2,500 rupees
to know the TSH level. So it means we need to go for such a large kind of process for the thyroid to segregate all the thyroid stimulating hormone from the blood. We need to have such a time to grow all the culture and medium. So it will take minimum of 2 to 3 days. Now people are trying to replace a fast, rapid and methodology to give the same information. So with these connections, so this is called potentiostat, which is a electrochemical based approach. It will give the same information instead of hours. It will give only within a minutes, maybe less than 1 or 2 minutes. So initially in the laboratory, we have a potentiostat with a high-end model, maybe a 10 to 20 lakh, to know the exact concentration of the each analyte. Based on the information, we are trying to develop a miniaturized version of sensor for various applications. This is our motto of divisions. Nowadays, there are numerous like a flexible sensor and smart watches is available to monitor the health condition of humans. So this is the chemistry which involves for all the sensing molecule. For example, the blood like a glucometer, there's a strip, small strip. Maybe I will show in this slides. So this is a glucometer. You can see there is a small strip which is preloaded with the enzyme called glucose oxidase. So to preserve the enzyme, we have to keep this particular small strip in the refrigerator for a 4 to 6 months period. So actually what is happening on the electrode surface? For example, so the black one is the electrode, the red one is called the enzyme, which is already preloaded. Once our blood reaches the biological moiety, that is the enzyme, it will undergo some kind of reactions to produce some other chemicals. For example, in this particular case, glucose oxidase react with the glucose and it will produce a gluconic acid as well as the hydrogen peroxide as a byproduct. So we are only measuring the concentration of hydrogen peroxide that will give the indirect information of the total glucose levels. Okay. So this is a highly accurate method because they are specifically identified a enzyme that can react with the particular molecule. But the main drawback of this enzymatic sensor is we have to spend more amount to get the enzyme from Sigma Aldrich or maybe some other company. We have to preserve the entire strip in the refrigerator conditions. So with this reason, now people are working in the worldwide in the non-enzymatic approaches. It means no need of enzyme. We can identify any nanomaterial that can also react with the glucose molecule and convert the byproducts. That byproducts we can measure through the devices. So this is the method to develop of in general. If you just see in sample category, there are different soil, water as well as a biological molecule we can detect using the sensor with the help of the analytes molecule or maybe a target molecules. For example, enzyme as well as antibiotic, so antibodies as well as DNA and RNA. That is the material which is preloaded on the electrode surface. So here, who and all contribute for a chemical, biochemical, nanoscience, biomedical and environmental based students can contribute for development of such kind of a sensor for their own applications. So as I already mentioned, to replace the enzymatic approaches, worldwide people are now focusing the nanomaterial based sensor that can used as a replacement of enzymatic sensors. So because of the advantage or maybe the growth of nanotechnologies. So as we discussed, there are different type of nanomaterials based on the shape or maybe the morphology, like a 0-dimensional, 1, 2, and 3-dimensional material can act as a sensor for sensing of various biomolecules and environmental molecules. So you can ask how these signal amplifications happen due to the nano effect. Okay. So this is the reason. You just take, if for example 5 cubic centimeter of a cube, if you cut into, that is slice into 24 times, if you spread the 5 cube size, the cube 5 centimeter size cube, it will cover the football ground space. So that is the importance of nanotechnology. So when we are going to small and small, there is a possibility of large number of active sites on all the surfaces. For example, if you take, this is a bulk material, there is a only available surface here on the 4 or maybe 6 side. If I convert it into 100 times, 100 into 6, maybe that much amount of active surface will increase, that can react easily with the target analyte and give the signal amplifications. Okay, that is the power of nanotechnology to increase the signals. So this is already we discussed. So these slides I put because of, you just to see the meter cost. Now the best meter or maybe a commercially the very accurate or maybe a good meter in the market, between 1000 to 2000 rupees we can get it. The cost of the strip is maybe a 10 to 15 rupees. You just calculate each analysis per day, 15 rupees into 2, 30 rupees per day into 30 days. We need at least 1000 to 1500 rupees. It is affordable for us, but the people, those who are in the poverty line, it is highly cost expensive to have such kind of small devices. So that is the motto to the government. They insisted us to develop as much as a low cost device and strip and chemical is possible for various detections, including health and environmental monitoring. So if you calculate the cost per month, it will come around 3 to 5,000, which is little expensive for the poor peoples. So this is also another example. Everybody heard this pregnancy testing kit, which is called a opto-electrochemical based device that can particularly sense the hormone called human chronic proteins with the antigen antibody based interactions. So once the proteins or hormone reach the strip which is already coated on the antigen antibody, there is a chemical reaction it will occur. The chemical which is already preloaded on the particular place, after the reaction, it will change its color. That is called the optochemical methods, the color-based sensing methods. So now, initially, the price of this particular kit may be at 200, then it reduced to 100. Now it is available in 40 to 60 rupees. But still, government want to reduce in less than 10 rupees for each analysis. So this is another example, recent days, to identify the COVID virus. So the people working in this particular company, along with this Serum Institute, they have identified the antigen antibody based sensing methods that can specifically catch the virus and change its colors. So it will qualitative information. After the qualitative, we have to go for a quantitative methods, that is a PCR and other things. So this is another example which all comes under the biological category. So the information what I want to just convey to the students, once upon a day, if you want to check your health conditions, if you want to check your blood test, your blood, we have to go to the center, wait for hours, and then they will come and collect your blood and they will ask to wait another 2 hours. At the maybe afternoon or maybe at the evening, they will give the sugar test. But nowadays, if you want to test, we have all the sensor devices which is miniaturized, and it will give a live monitoring, maybe like these images, just to see all the information of the particular elderly people, which is monitored by the smart gadget, will be sent to the children's. They are in US or maybe UK. They will immediately contact their family doctor and advise them, sir, my father's health is not in good condition. You please go and see my father's. So in such kind of improvement has already happened in the area of health care sensor. But coming to this environmental based sensor, still we are lacking for monitoring of many like a pathogen, organophosphate, explosive, antibiotics and heavy metals. We still yet we are related to the traditional approach. So as I mentioned, those the electrochemical sensor or maybe a whatever opto sensor is a highly sensitive or selective. The major issues associated with the sensing technology is the like interferent effects. For example, if I want to monitor the pathogen which is available in the water, not only the pathogen is available, there are numerous amount of heavy metals, pesticides and other contaminant may also occur or may be available on the particular water surface. With the presence of so many contaminants, how I can specifically tune the sensitivity or selectivity of my sensor to particular pathogen is a really challenging task. So for these reasons, we are first what we are working to identify the system first. For example, if I want to monitor the water, I have to collect the monitor, I have to collect the water and test the water with the traditional method in the repeated manners to know that these are all the available interferent in the particular systems. So based on the concentrations, we try to eliminate the unavoided, unwanted, the heavy metal or whatever may be through some treatments, and then we will design the sensor to particularly catch the target analytes. So this is the one way to increase the sensitivity and selectivity of the sensor. So we are working for various aspects, which includes soil monitoring, like a soil NPK sensor. In addition, the macronutrients, we are also working for the micronutrients like zinc, copper, and other ions through opto-electrochemical approaches. Like as Sir highlighted, in collaboration with Agriculture College Madurai, we developed a portable soil sensor that can give a information nitrogen, phosphorus, potassium, pH, as well as the electrical conductivity, 5 parameters. So the entire analysis we optimized in such a way that the duration of all 5 parameters we can able to complete within 20 to 25 minutes through optical methods. So we have identified some chemical that can selectively react with the nitrogen, phosphorus and potassium and create some color combinations. So these are all some commercially available sensors. Some companies are sent to us. We just re-engineered and identified this. There is a lot of mismatch or maybe it is a not reliable method to say the health condition of a particular NPK, because they are claiming that it is a conductor based sensor or some other based sensor. But when we are doing some re-engineering, that is not the correct sensor to say the soil health. So the points, we have to do lot of experiments and compare with the traditional, like a method of, for example, if nitrogen, we have to parallelly do the Kejeldal method as well as the sensor method for 1,000 or 2,000 number of soils. We have to arrive some difference in the values, then feed all these value into the system, that is the portable system. But in such a case, they put some simple, some stainless steel electrode and claiming that this is a conductor based sensor which is giving a accurate values. People are still buying. The cost of this sensor comes almost like a 20,000 rupees. Whatever the results giving through this sensor, they are believing that based on the sensor, they are feeding to the particular crops. They are spending their lot of money in an unwanted way. So we try to figure out and help the farmer, and we are continuously working for the soil sensor development to give accurate informations. So in addition, in recent days, these are all the highly like a dangerous things like a polyaromatic hydrocarbons and antibiotic pollution in the soil and waters. Because now in all the home we have a very attractive that cooking vessel which is already loaded, already coated with so many polyaromatic hydrocarbons. Okay. So when we are continuously cooking, so there is a chemical compound which is called a aromatic hydrocarbon. It will start to come out and it will reaches our blood through the food. At the end of after so many years, it will create some kind of carcinogenic effect, particularly the cancer related diseases. So we also try to work on to identify different kind of polyaromatic hydrocarbons, and this is another class, that is antibiotics. Now these antibiotics people are using like anything, and they are buying, use and throw it simply to the soil and water. Now this antibiotic resistant also a threatening disease for the children. So we do work on the quantification of antibiotics in particular water, soil, in particularly the area where there is a numerous chicken farms, in particularly this Namakkal and Karur related area. We are working to identify the antibiotic contaminations. So these are also some of the results from our laboratory we have arrived for hydrocarbons. So the electrochemical based sensors show a excellent sensitivity, but we are trying to overcome the interference effect. This is some preliminary results. So we are in the working on to how to avoid the interference molecules. So this is already published the data of antibiotic sensor chlorotetracyclines, which is hugely available in the chicken farms. They are used based on the literature survey as a medicine as well as a growth factor to increase the weight of the chickens. So the unutilized antibiotic called tetracycline also a health impact for the children particularly. So we try to develop electrochemical based methods to identify the exact concentration of this chlorotetracycline, and this work already published in Journal of Material Chemistry. So this is another type of optochemical sensor for detection of the same molecules, because we are parallelly working on different aspects like optical methods, electrochemical methods, and other impedance, that is a charge based methods. So among these, this is a colorimetric based sensor. We have developed some nanomaterials called quantum dots in the liquid form. We need to just add a water molecule in a drop. If the water which contains tetracycline, it will change the color from the gray to the blue colors. So normally we used to do the calibration with different concentration, that is a MRL, maximum residual level, which is proposed by the ICMR So we do work with the lowest to the highest end, and we record all the different concentration and the color through UV spectrometer. And based on this calibration curve, we can easily identify the amount of particular pollutant available in the particular medium. So these are all some of the work already submitted to the journals. So this is another example of environmental pollutant called nitrophenols. So nitrophenol also used in a huge way for various manufacturing industries. So these contamination also need to be monitored. So we have developed the copper-based electrochemical methods to monitoring the exact concentration of the particular nitrophenols. So you just see whatever the target analyte, accordingly we have to design a receptor molecule that can easily make some coordination bond or maybe as a kind of reaction and produce the current. This is the current value. The right side is the corresponding electrochemical current. Based on the intensity, we can say the particular concentrations. So this is another development to work on 4-chlorophenol. It is another kind of environmental pollutants using the manganese oxide based electrochemical system. So with this system also we can able to sense the particular 4-chlorophenol in a nanomolar concentration in the water molecules. So most of the work we already submitted for publications. So all the work in the kind of review conditions. So this is some kind of carbon-based material, graphitic carbon nitrides for sensing of nitrides in the water molecules. So it will also produce a very good signals, electrochemical signal, and based on the current value, we can easily say that. So all these measurement, it will take less than 1 or 2 minutes. We need to add just the water molecule into the electrode system, just to give a on button. It will come up within a 1 minute. So we can analyze like 100 number of soil or maybe a water sample per day. If you want to do the same in a traditional method, at least it will take 2 months time to analyze 100 or 150 samples. So these are all some of the examples to show to the students for electrochemical based organophosphorus pesticides. So the point I just want to convey, whatever may be the contaminants or whatever may be the analytes you want to measure, we can design the electrodes that can easily catch and react and produce some current. That is the points I just want to convey. So these are all the heavy metals can easily detect with the electrochemical and optical methods within a less than. These are all some colorimetric. You just see how a small difference of the concentration, it can change its color. So this is the power of the optical sensors. So accordingly, we have to identify some nanomaterial synthesis in the laboratory and add on the particular environments. So in addition to this, we are also working on these foodborne pathogens detection using immunoassay, that is antigen antibody based sensing. So it will be a reliable method, but it is a little expensive because we have to purchase all the antigen and antibody with a high quality, so that it is little expensive. But based on this target analyte, there is no other options. We have to work with this antigen based sensor. So for conclusion, if you ask what's the scope, opportunity and challenges, the scope of the overall expectation is we have to develop a low cost all-in-one electrochemical sensors. For example, if I want to monitor the soil environment, the sensor, it will give the information of at least 5 to 6 parameters rather than a 1 parameters. So that is called all-in-one electrochemical sensor. It may be a portable, so we can carry wherever we need, even for field or maybe in the laboratory. At the same time, it should be a cost effective. For example, the whatever I discussed, the soil sensor, our DG madam has to develop with less than 5,000 rupees a device. So with the help of electronics people, we have identified the low cost PCB board and other small electronics. With our chemistry knowledge, we are identifying some chemicals with that will give a color. So we have developed that sensor with less than 5,000 rupees, a prototype sensor. In connection with device development, if you just type in the Google or somewhere, electrochemical or maybe optical based sensor, there is 1,000 publication may be available. But if you just see the commercial availability, there are very few sensor is available because so the people decide to think that once the result is good, they just publish with a high impact paper and then they leave it. They will identify other problem and they will keep on switching to one problem to number of problems. So those who are interested in the youngsters, you just identify any one problems. For example, if you want to monitor your water environments, at least focus a systematic development of a device or maybe a protocol that will give maximum of output, and then you can switch to the next one. In connection with the challenges, the stability and reproducibility. As we discussed, the enzymatic sensor is highly stable. Due to that reason, we have to spend little more money and we need to have that refrigerator conditions. In the case of non-enzymatic approaches, the sensitivity is good, but the stability is poor. The sensor what I have developed, it will give a 100 microampere current morning. If I take the same electrodes, same material, if I measure in the evening, it will give 95 microampere current. So these 5 microampere difference, it will keep on increasing to 10, 20, 30 over the period of time. It means we have to have such kind of stable environment that will not allow to decay the developed material and hold at least a period of 2 to 3 months. So most of the sensor, like a strip based sensor, they will put the expiry date up to 6 months. After 6 months, we cannot expect the same stability or maybe a quality. At least the developed sensor can give the same information for 4 to 6 month time with the low cost. So that is the main motto. We are working on these aspects in particularly. In addition, the problems what we are facing, sensor working in the real-time environments. For example, I am collecting some water from here. I can do my result in the laboratory because all the chemical is highly pure, whatever we are having. I can measure the concentration which is available. But if I put the same electrode in this real-time environment, it will not work, or it will work in the little expected range. So this also we are trying to figure out for modification, some kind of treatments. I think with this, I will stop the presentations. I'm very happy if you have any questions. Thanks.
Of course, we are generally using it, but you are using it as a food. That's one that the vaccine for presentation. But the question is the reliability, that is the validity of the use of sensors as finding the quality characterized like for example, also these are not we use only this is developing, but it will also standard chemical. When you use the calcium sulfate as conductivity. So likewise, along with the cells are developing, we have such any standard chemicals for producing.
Yes, sir.
How to standard keep the standard?
Yeah.
Now we need to fix the standard separately. We will fix the standard, then go for the standard. Right.
Yeah, it's a really excellent questions. For example, sir, I will explain in such a way that if I want to test the nitrate, soil nitrate, what we do, we first make a calibration with sodium nitrate from the lowest, based on the agriculture experts, they give some ranges like 10 from 5 ppm to maximum 40 ppm is the nitrate available in the soils. So what we have to do, we do make a color with the 5, 10, 15, 20, up to 50, maybe sometime with 100 ppm also. We do this in a consecutive like a 5 to 10 experiments and measure the concentration through UV. So then we used to have that real samples and identify the particular concentration of nitrate in the particular mediums.
So calibration of the
Yes, sir. Yes, sir.
to calibrate the you have to get this tested.
Yes, sir.
Also, for example, even if you talk about the parameter to design the sensing of the compounds. For example, these are the sodium nitrate. What is the use of such a particular solution? Okay, there is some feelings will be there. But when you go through the soil, the real time soil estimation, the chemical of the soil will vary from acidic to alkaline. That's the sensor.
Yeah, this is another excellent question. Sir, in these particular aspects, only the agriculture scientists help us. They have some soil mappings. For example, zone-wise, they have some mapping based on the acidity value. So what they will give us, they first collect all the acidic soil, neutral soil, alkaline soil from various places. They do traditional way of measuring the nitrate, phosphorus, potassium, and other parameters. So they will give the same soil sample to us. So we are testing with the particular soils. Validations. Once after successful making the color, we used to seek the help from Dr. Kannan in Tamil Nadu Agriculture University, Madurai. He will give us. Yes, sir. Now, yes. Yes. So this is a routine way we are optimizing the particular concentrations.
Make some calibrations. There's all of the different types of chemicals.
Yeah. Yeah. No, ma'am. No, ma'am. Actually, yeah, I accept you. I agree with your points. So we cannot replace the traditional values with the sensor values. We try to correlate between the traditional and the sensor value. Always the values little bit like this from the traditional and the sensor. Yes, yours okay. So the point what we are, yes, sir. Yes, ma'am. I agree with that. For example, if you test like 100 sample, almost like a 60 to 70 sample only, it will reliably give the results. The 30 sample, we unable to do that. So we are still focusing on working how to improve that results. So whatever we learned from the agriculture scientists, they are always highlighting us soil is more worse than our health conditions. It will not always the same. For example, in the today condition, it will give one results. Maybe tomorrow we will not expect the same conditions. They are always putting some different. Yes. Yes. That is also different on the company to company meter. From student side, any question? I am Ma'am, right now we are trying to identify some gas sensors, working on the gas sensors. But too much of focus, it's highly difficult, ma'am.
The motility is inversely proportional to the area. For example, you give an example of health application regarding the so this one which is using income. Really, and actual values may vary, but there is something in the smartphone. So it's a very like the reliability is reduced, the reliability is important.
Yeah, it's excellent. I agreed. So whatever the best sensor which is available in the market, for example, the best glucometer, it is having a 30% of error. It is more than 25% of error, but doctor may agree that they want to have an instant value because we are only worrying about when the sugar level more than 150. If it is less than 150, we will not worry about. So all around the world, people are accepting the 20 to 30% error for these kind of portable sensors. So at the same time, people are working to give a more accurate value, but it is possible with multiple application like a help. For example, you need to have a very good electronic person. We need to have a particular, for example, agriculture purpose. We need have a expert in agriculture. They will give you exact information. In such kind of development, maybe we will improve the relay. It's like artificial intelligence. You are asking. Yeah, exactly. Okay. But it should not vary more than that values, like a 15 to 20% here. No, we can use the same soil sensor in such a way that we designed because we put some miniaturized like a EC and pH probe in the soil. So once you use that clay soil, after that you wash it and you can use to the different soil. So we use this commercially available probe for EC and electrical, pH and electrical conductivity. In the case of NPK, it's not a matter of soil. Whatever the availability of the quantity of nitrate, it will produce the consecutive colors. So we can use any soils, any kind of soils, any number of soils. Thank you.
There are lots of selection available. So when I was last time I was to the International Center for Molecular Language. So I was 15 days program. One of the scientists is using the sensors there. It's limited. Now the sensors are available in the market. But we collect many sensors. I mean, we testing these more. More available more this
Yes. So we always try to figure out with the traditional methods. For example, I have 5 sensors with a different 5 companies.
People will walk like so we will add the person to the traditional the way of analyzing. So that is we will say that conservative.
Yeah, it's a nice question, but I can put the answer in a way. For example, you are measuring the soil pH. What we will do, this is a method we learned from the agriculture scientists. They will collect the soil from different locations with a different depth and they have some procedure. The same we will follow it. So we do the analysis and we identify like a number 1, 2, 3, 4, 5 samples in the same locations. We measured the pH. For example, if it is acidic, the first number 1 soil, it will give 4.5. Number 2 soil, the values, it will vary 4.5 to 4.8, but it will not go to 7. So the third sample, it comes again to 4.2. The fourth sample again 4.6. This is the information we measured. So we try to normalize and say that it is an acidic soil rather than the values, like exact values. Acidic, neutral, and alkalines. We learned that there is a range between 4 to 8 for the soils. It will not beyond that. It's excellent questions. For example, I can answer in such a way that right now we are working with the chemicals that is purchased from Sigma Aldrich with 99.999 purity. What we will do, we will also work on some Indian company with 99 or maybe 99.2% purity, but the cost is huge. The difference is huge. The sodium nitrate, what we are purchasing from Sigma, maybe 100 gram is 20,000 rupees. The same sodium nitrate from the Indian company, 100 gram may be less than 2,000 rupees. So we will try to get with the same chemicals, maybe the values little vary. But for example, in the Sigma chemical, it will give 99% of accuracy. The SRL or whatever may be the chemical, it will give 96 to 97% purity. When we are discussing with the expert, they are saying that this type of number is not a matter. We need to say yes or no, or sometimes the kg per hectare on the conversion factor only, it will help. So in such a way, we try to reduce the chemicals, electronics, and all others through indigenously, so that automatically the cost.
That sounds wrong.
Yeah. No. Initially, what the way we are doing the research, if tetracycline is a pollutant, we will collect all the group of tetracyclines, tetracycline, chloro, oxy, whatever may be substituted tetracyclines. We are working on all the tetracyclines. But sometimes among the tetracycline, which one is more carcinogenic is a importance. In such aspects, we identified this fluoro compounds is a little more carcinogen than the bare tetracyclines. So, but we are working on all kind of tetracyclines. The best example is COVID sensor or maybe the pregnancy testing kit. That is a commercially available. No. For pollutant, they will not go for a antibiotic based sensor. They will work on the non-enzymatic based sensor. But there is not a specific sensor available for commercial for pollution detections. Till date, people are comparing with the traditional methods or maybe some kind of